Yes, class, is this audible now?
Yes, ma'am.
All right, so we had completed till equipotential surfaces in the last class. So what is meant by equipotential surface, Khalid? What is an equipotential surface? Okay, Salman and Khalid are not here right now. Samaira, you tell me what is an equipotential surface?
The surface at which at every point the potential is same.
Potential is same. The point at which the surface, actually the surface at which, if you take any point, if you consider any point, then the potential will be same. Whatever is the value of potential, that will come out to be same. So Sarah, what is the relationship between electric field and potential? That we have also had seen in the last class only. Relation between electric field and potential. Yes, Sarah.
Electric field is equal to dV by dr.
dV by,
dr.
is this enough? dV by dr. Only dV by dr.
minus
dV by dr. This negative sign is important. No, see, whenever we were writing electric field or whenever we differentiated potential, we always wrote this negative sign. So it has some significance. What is the significance of this negative sign, Hania? In this E is equal to minus dV by dr. What is the significance? Yes, Hania? Anyone else? What was the significance of that negative sign? Okay, Khalid, you're there.
I had net issues.
Okay, fine. All right, so Salman is not here right now. Direction along electric field where potential decreases, correct. Just revise and come. See, electric field was what? As I told you, there were two important points. First point was what? It said that electric field is the potential gradient. Potential gradient means potential divided by the distance. That rightly said by you. It was E is equal to minus dV by dr. The significance of this negative sign is that electric field is directed where the potential decreases. So this is the significance of it. Now we'll start with the last topic of your potential part. Then we'll do capacitance. From your potential, electrostatic potential energy is left. So now see, understand what is meant by electrostatic potential energy. Whenever you get the term energy, no, just understand. See, if you have two or more charges or minimum two charges possible, if you have two charges possible, let's say Q1, Q2, two charges are there. So both of these charges will be exerting force on each other. Now, whenever you have such a case where force has been exerted between two bodies, then we say there is interaction among them. Interaction means what? Interaction basically means that both of them are exerting force on each other. Q1 is exerting force on Q2. Q2 is exerting force on Q1. Even if you know the separation between them, let's say small r is the separation, then you know even what force they are exerting. K Q1 Q2 divided by r square, your Coulomb's law. So you know that as well. So electrostatic potential energy arises from this interaction only. Remember, there are how many kinds of energy? If we talk about the basic energies that we are aware of, we know we have kinetic energy in nature, we have potential energy in nature. So kinetic energy, if I ask you what is meant by kinetic energy or what is the cause of kinetic energy, then all of you will say that it comes because of motion. Whenever motion is there, then kinetic energy comes. Apart from this, the second energy that we have is the potential energy. Now see, in case of potential energy, it's not only by virtue of its position or change in position, shape or size. It comes due to, mainly it comes due to interaction. Interaction means what? If there is exertion of force. So whenever there are two particles together, or even if you say two charges are together, two masses are kept, not only considering about these two charges, even if you have two masses kept together, they will be exerting force on each other. And whenever you see this, that two bodies, two particles, two entities, these are exerting force on each other, that means what? That there will be an associated potential energy with it. Whenever there is motion, then you are right, it will be kinetic energy. The other energy, that is potential energy. The reasons or the causes of potential energy, it's not just that there is change in position or there is change in configuration, shape or size. Apart from this, the major reason is that the interaction between the two charges. Interaction means basically forces. Wherever you see forces are being exerted, there will be potential energy. If not two charges, if I say there are three charges, Q1, Q2, Q3, let's say there are three charges or three masses or three particles are there. Q1, if I talk about the electrostatic energy or electrostatic potential energy of Q1, then Q1 is interacting with what? Q1 is interacting with Q2. Interaction means what? Force. Apart from this, Q1 is interacting with Q3. So it means on Q1, there will be two potential energies. Two potential energies will be possessing. One potential energy will be due to Q2. This potential energy will be due to Q3. So in your questions, also in your examination, you will be given systems where there are n number of charges. So you have to find out on whichever charge it is asking you to calculate the potential energy. You have to first figure out the interaction or the force that is being exerted with it. All right, so let me write down only the cause of potential energy first. So firstly, cause of potential energy, you should remember. Cause of potential energy. So this is basically the electrostatic interaction. Whatever electrostatic interaction occurs, that is the cause of it. Electrostatic interaction means the exertion of force. Whenever forces are being exerted, there will be a potential energy associated with the system that you have. Particularly for each of the charge that you have, there will be associated potential energy with which the charge is interacting or with which the charge is exerting force. Now, regarding specifically talking about what is meant by electric potential energy, electrostatic potential energy, if I talk about electric potential energy. Now, being specific about electric potential energy. See, if I have two charges kept at infinity, let's say Q1, Q2, both of these charges are kept at infinity. Let's take three charges, Q3. Q1, Q2, Q3, all these are kept at infinity. Now I am making up my system. So firstly, I bring up Q charge from infinity to a particular point. From infinity to a particular point, I have brought this Q1. So here work done will obviously be zero because from infinity you are bringing the first charge. Energy will be zero. Reason is that there is no interaction right now. The single charge will interact with what? There is no other charge present to interact with it. Then I bring up this Q2. I assemble it over here with some distance between Q1 and Q2. Then I bring this third charge, Q3 as well, and I assemble it. So all the work done that I am doing in bringing all these three charges from infinity to the point, all the work done in assembling these charges, that gets stored in the form of potential energy. That we call it as electric potential energy. Regarding electrostatic potentials, definition, that was what electrostatic potential was: work done for moving a unit positive test charge from infinity to a particular point. Regarding electric potential energy, it is the work done by the external force in carrying charges from infinity to the respective position. If you have to assemble a system, then you need electrostatic potential energy. All right. So that is the definition of electric potential energy. Now, if we calculate electric potential energy for 2-point charges, if we have, let's take first only for 2-point charges, then we'll calculate if we have more charges than 2. So electric energy or potential energy of a system of 2 charges. Potential energy of a system of 2 charges. If you have to assemble 2 charges only, and both of the charges should be located where to assemble? Firstly, where the charges should be there? See, if you have 2 charges, you are using your potential energies concept. So initially, where are the charges?
At infinity.
Infinity, correct, Samaira. At infinity, both the charges are there. Now we are assembling it. We are forming our system. So let's say Q1 and Q2, these are both the 2 charges that are kept at infinity. Let's say this is infinity and both of these charges are kept, Q1 and Q2. These are the 2 charges kept. Now at a particular point, or let's draw it graphically. This is y-axis, this is x-axis, this is my origin. So now firstly, I have brought charge Q1. From infinity, I have brought this charge Q1. So is there any other charge present with Q1 right now?
No.
There is no other charge present. It means there won't be any potential energy. That is, if I talk about the work done in carrying Q1 from infinity to, let's say, this point is A, to A. This work done 1, this is 0, because there is no other charge present to interact with it, to exert force on it. So it is 0. And let's take this distance. Let's say this is R1 vector. Now I have brought Q2. Now Q2 has been brought. Let's say this point is B point. And the separation from the origin, I'm writing it in coordinate system. This is R2. So the relative separation between Q1 and Q2 will be what? This will be R12, relative separation between both of them. But R1 is the separation of point A from origin, and point B is separated from the origin by this distance R2. Now Q2 and Q1, two charges are present. Will there be any interaction now? Or will it be still 0?
They will have interaction.
They will have interaction because two charges are now present. So we have to find out what is the work done. So see, work done in carrying Q2 from infinity to where? To point B. That is what we are finding out. So work done to carry a charge from infinity to a particular point is what? If you remember the relationship between work done, charge and potential, that was what? What was the relationship between work done, charge and potential? Anyone? Definition of potential only has the relation. Yes, Mamuna. How will you relate charge, work done, and potential?
VA equal to W infinity A by Q.
Correct. Work done for a unit positive test charge is only potential, no? What was the formula that we seen? We had seen not only the formula, even definition of potential was what? Work done for a unit positive test charge. That was only the definition of potential. So if I have to write work done will be what? Potential multiplied by the charge. Now the charge is what? Charge is Q2. But the potential will be generated by which charge? Q1. So this will be what? This will be VB minus V infinity. This is the work done in carrying charge from infinity to point B, which is equal to the product of charge and the potential difference. So difference, how do you calculate? Final minus initial, no? Final is what? VB, at which Q2 has been placed. V initial was what? Infinity. So V infinity is 0. Potential at infinity is always 0. But potential at B point. Now see, potential at B point is generated because of what? Because of Q2, no? Q2 is interacting with Q1 is interacting with Q2. So potential here will be because of the charge Q1 only. And separation between Q1 and Q2 is what? R12. So we know the formula, general formula for a point charge is what? KQ divided by R. So K, Q is what? Q1 divided by R means separation between Q1 and Q2, point A and point B, R12. This is vector R12. So let us put these values to check what is the work done in carrying this charge Q2 from infinity to this point. This will be Q2 multiplied by KQ1 divided by R12. So W2 is what? W2 is K, Q1, Q2 divided by R12. So if I talk about the total work done will be what? The sum of the first work done, which was 0. W1 was what? when no charge was there except for Q1. It was 0 W1 and W2 is this that we have calculated. So if I talk about total work done, this will be W1 plus W2. So W1 was 0 plus K Q1 Q2 divided by R12. Now see, this work done only gets stored in the form of potential energy. This total work done, this gets stored in the form of potential energy. So potential energy will be what? This will be only equal to the net work done, which is K Q1 Q2 divided by R. R12 means the separation between both the two charges. So if you have a system which has two interacting charges, and if you have to assemble the system, the total energy required will be what? K Q1 Q2 divided by R12. Where Q1 and Q2 are the charges, K is the constant 9 into 10 to the power 9, and R12 is the relative separation between them. Is this clear?
Yes, ma'am.
Yes, ma'am.
So just note it down, then we'll see if we have more than two charges, how to tackle that. Written? So by now, all of you must have completed it. If anybody is writing, just let me know and I'll stop. Otherwise, let's do potential energy for system of endpoint charges. So before that, we discussed if we had only two charges in the system. If we have more than two charges, n number of charges present. So see, similarly, I'll draw it on the coordinate system. This is x-axis, this is y-axis, this is the origin. So I have various charges. Q1, Q2, Q3, Q4, Qn. N number of interacting charges are present. Now see, again, I'll bring the first charge, Q1. Let's say this is point A. So Q1, Q2 we have already discussed, so this is easy. From the origin to the point A, the separation is R1. So what will be work done? W1.
0.
0. It will be 0 because there is no other charge present. So work done W1, this is 0. So similarly, we'll be calculating for the charges and we'll see what is the net work done coming. Then I bring this Q2. Q2 point B, separation. Let me draw the separation. This separation is R12. So we have already calculated the work done for W2. What will be W2? Yes, right now we have only done. What is the work done? That is the energy.
K Q1 Q2 by R12.
Correct. K Q1 Q2 by R12. This will be K Q1 Q2 divided by R12. Reason is that this is the charge. This is basically work done is written as potential into charge. This is potential V, this part. And this is the charge that we have, Q2. So V into Q is what? Work done. So that is the work done, K Q1 Q2 by R. But right now we don't have only two charges. Now we have Q3 as well. So I'll bring Q3 as well, let's say 2 point C. And this separation is R3. Now look at all the separation. This was R2. See, there are three charges. So there will be three kinds of interaction. Q1 and Q2, there will be energy associated with Q1 and Q2. There will be energy associated with between Q2 and Q3. This is what this separation is, R23. And there will be energy associated with A point and 3, Q3, means Q1 and Q2. So Q1 and Q2, this separation, let's say this is R13, separation from R point to 3 point. Let me draw it again. This is R13 separation. So is this clear, the separation between all the three charges right now? There are three charges present. Now see, calculating work done for Q2. Now work done in carrying. See, all the steps are repeated. This is the same step that we are repeating. It's just that we have the charge Q3. So work done in carrying Q3 from where? From infinity, because from infinity we are assembling this Q3. So work done in carrying Q3 from infinity to the point C, I guess. Yes, to point C. This is equal to what? Work done in carrying the charge from infinity to point C is equal to charge multiplied by the potential difference. So Sarah, tell me, what will the potential difference be? V infinity minus VC or VC minus V infinity? Yes, Sarah.
VC minus V infinity.
Yes, VC minus V infinity. See, the reason is what? You have to find out the change in potential difference. How do you calculate the change? Final minus the initial. The point is coming from where? From infinity. So infinity is the initial point. That's why you write infinity after. And what is the final point? The final point is the point C. So that's why you will write VC minus V infinity. This is the work done. Now we just have to put in the values. Regarding VC means potential at point C, there will be potential generated by not only Q1. Now this time there are two charges present. So there will be potential generated by charge Q1. There will be potential generated by Q2. That will be exerted on this third charge Q3 that has been brought. So potential work done is what? Charge will be Q3 because the forces are being exerted on Q3. We are taking Q3 as the reference. Q3 has been shifted from infinity to the point. So work done 3. This will be what? Q3. Now regarding VC, you have the first charge as Q1. Q1 is the charge that is located on point A. So yes, Salman, you tell me. This is charge Q1. This is charge Q3. You know the separation between them, Q1 and Q3. What will be the potential due to Q1? Yes, Salman. The general formula for potential is what? KQ by R, if you remember. So at point C due to point A, what will be the potential? Yes, Salman, you there? Khalid?
Yes.
At point C, what will be the potential generated by point A?
VCE equal to Q3. No.
Not
W.
VC. I'm not talking about the whole VC. I'm just giving you what? This we have already studied. No. Potential due to a point charge is what? What is the potential due to a point charge, Khalid? General formula, general. Yes, Khalid, it's KQ by
Q
R.
by R.
No? Yes,
Yeah.
KQ by R. Now see, just focus on Q1. Q1 is the charge that is generating the potential. At Q3, what will be the potential? You know the general formula for potential due to a point charge. Just put the values. Tell me.
KQ1 upon R13.
Correct. Perfect. See, the general formula for potential is what? KQ divided by R. K is the constant. That will be same for everything. Charge is what? Potential is generated by Q1 now. So it will be K Q1 divided by R. R is what? The separation of charge to the point that we are calculating the potential. So charge is where? At point A. The point that we are calculating the potential is what? Point C. So the separation between A and C is what? R13. So it is KQ1 divided by R. Okay, Salman, it's okay. We were just discussing what is the potential difference due to Q1. So VC will not only be this. This is a part of VC. VC will be K Q1 divided by R13 plus K. Now Q2 will also be there. Not only the charge generated by Q3, and not only the potential generated by Q1. On Q3, there will be potential generated by Q2 also, no? So now, yes, Salman, if you're back, you tell me, what will be the potential at point C due to point B? This is the general formula. What is the charge? Yes, Salman.
K Q2
Yes.
Q3 by R.
K Q by R is the general formula for potential due to a point charge. So K, now what will be the charge?
K Q2 Q3.
Q2, only Q2, Salman. See.
Only Q2. Okay.
Okay, potential is a property for a single charge. You're not calculating the potential energy right now. I'm just asking you what is the potential. So see, at this point, C point, the potential is generated by Q1 as well as generated by Q2. Q1 we have discussed. If we are talking about Q2, so just focus on Q2. Q2 is your charge. So it will be K Q2 divided by what?
Divided by R23.
R23, perfect. Because the separation to the point and the charge is what? R23. Now you got the whole potential for it. So this is K Q2 divided by R23. This is the work done, W3. So if you multiply it, this will be what? This will be K Q1 Q3 divided by R13 plus, I'm just multiplying it, opening the brackets. This will be K Q2 Q3 divided by what? R23. This will be the potential energy. This will be the work done. Are you all satisfied with this?
Yes, ma'am.
All right. Now see, if we had Q4 also, so I'm not drawing it and writing. See the logic. When there was a single charge, no work done was there. When there were two charges, one work done was there. Why? Because of the interaction between both these two charges. If three charges are there, there are two interactions between these two, If we have four charges, so see, if you have four charges, if you have a fourth charge, if you are bringing work done to calculate Q4 from infinity to point D. So work done 4 will be what? See, firstly, just imagine number of interactions that will occur. If you are talking about Q4, how many charges are already present? Q1 is already there, Q2 is already there, Q3 is already there. It means first potential energy will be generated between Q1 and Q4. So it will be K Q1 Q4 and the separation between Q1 and Q4, that is R14. That will be R14. No, I'm just taking general terms. Plus Q4 is interacting with what charge? 1 we have considered. Next, Q2. So it will be K Q2 Q4. Q2 Q4 divided by what? Divided by R24, means separation between R2 and R4. This is just generalized terms. Q2 we have also considered. Regarding Q3, Q3 is what? Q3 will be K Q3 Q4, means the constant multiplied by the charges, both the charges that you have, divided by the separation R34. Is this clear? How to write it in general terms if you have Q4 with you? So there are three interactions because three charges are already there. So the fourth charge will be interacting with all the three of them. Is this clear? The work done 4. Just let me know, all of you. What about the others? Sarah, Hania,
Yes, ma'am.
Memuna?
Yes, teacher.
Yes, ma'am.
So see, work done. So these are individual work done. If you are asked to calculate individual work done, you have to calculate in this manner only. Consider the charge, count the number of forces or interaction that are occurring. K Q1 Q2 divided by R is the general formula. But if you have to find out net work done to make up the system, that is the potential energy of the system, that will be what? Okay, first let us write for Wn. If you have n number of charge, what will it be? Qn will be interacting with Q1, so it will be K Q1 Qn divided by R1n. Then this Q1 will be interacting with Q2, so it will be K Q2 Qn divided by R2n. This will be interacting with Q3, Q4 and all the charges present. So this will be what? If you have 5 charges in the system, there are 4 interactions. So it means if there are n number of charges, there will be n minus 1 interaction. No, because for the first charge we have work done as 0, we don't count it. So there will be 1 less. So general terms I can write it as Qn minus 1 multiplied by Qn divided by Rn minus 1 2n. In general terms, no, n minus 1 to n. Just a general formula like this. You can keep on adding it. K Q3 Qn by R3n, K Q4 Qn divided by R4n. So it can go on. So if I talk about the total work done to make the system, this is for general case. If you are given any charge and you are asked to calculate what is the work done or what is the potential energy of this particular charge, calculate and tell, then you can use this. But if you are asked what is the potential energy of the system, so total work done will be what? Total work done will be W1 plus W2 plus W3 plus W4 up till what? Up till Wn. All the n number of charges present. This will be Wn. Total work done. So work done will be what? It will be first 0 for work done, W1. W2 we had seen K Q1 Q2 divided by R12. Then for W3 we had seen K Q1 Q3 by R13 plus K Q2 Q3 by R23. This is what? This is W1. This is what? This is W2. This is W3. Plus up till what? The general formula of it. Wn is what? K Qn minus 1 Qn divided by Rn minus 1 to n. This is Wn. Now all this work done gets stored in the form of potential energy. So I can directly write this is U only, whole value. This is same. Why? Because the whole work done, this gets stored in the form of potential energy. Work done gets stored in the form of potential energy. So this will be the same. So you cannot write it all the time in such a long manner. How many charges are there? You don't know. So just summarizing it. 1 by 4 pi epsilon naught, the K that is common already. If you write the summation from I is equal to 1 means from the first charge. This is for the first charge. And for the second charge, let's say J is equal to 1. To what? To n. It's just a method to write it. Q1, Qi, Qj divided by Rij. The condition is that not R. I and J should not be equal. Because then that will be square of it. I and J should not be equal. This is just a method to write it. It means I is 1, Q1, J is 1, Q1. But both of them cannot be together equal. Then I is 1, J can be 2, Q1, Q2. I is 3, J can be 4, Q3, Q4. So just a method to represent it. You don't need to learn this. It's just the summary of how to write the potential energy. So just concluding it once again, how do you write the potential energies? If you have various charges with you, firstly calculate work done for each charge. If you are asked the potential energy for a particular charge, that will be the work done. If you are asked the potential energy of the whole system, then work done for all the charges get added up, and this whole work done, this gets stored in the form of potential energy. That is, the general formula is there in front of you. Now, is this clear to all of you?
Yes, ma'am.
So if there are any doubts, you can ask me, note down this, then we'll do questions. From the questions, with the help of questions, it will get clear how to utilize this. So you have to count it. If there are 3 charges, Q1, Q2, you have to consider. Q2, Q3, you have to consider. All right. Whatever charge you are taking out, just calculate number of interactions, whatever are the separation between them. So general formula will be this only, K Q1, Q2 divided by R for potential energy, general formula. This is for potential energy, this is for potential. See, I'll help you with the rest of the parts. First, at least all of you should submit me the answer of the first part. The general formula of potential energy is what? K Q1 Q2 divided by R12. Whatever is the separation between them. K Q1 Q2 by R only. So that is the general formula. The charges are given to you. This is the general formula. So find out potential energy. All of you should submit this answer. First part. This is mm. 3 mm, 2 millicoulomb minus 3 microcoulomb. And don't take the magnitude of the charges. If it is minus, then consider it as minus. You will get the potential energy as minus. Yes, Salman, take K as 9 into 10 to the power 9 only. This K. Then see what's your answer. Samira, is this your complete answer? Salman, your answer is right. There's some error in the power of 10. Just check it once again. I think while conversion, you must have committed some error. Just check it. Otherwise, I think you will be able to find out the right answer. Samira, just check. There will be something else also associated with this, whatever the answer you're giving. Others also submit. The calculations are not so lengthy. Hania, Khalid, Memuna, Sara. Yes, Sara is right. So the correct answer has been submitted by Sara. Hania again, errors. No, okay, Hania has submitted this one, corrected. Hania is also right. Hania and Sara, both of them are right. Now let's discuss it. I think the calculations were very easy. 3 and 3 can easily get cancelled. 2 multiplied by 9 gives you 18. So magnitude you can easily find out. It will be related to 18 only. Okay, Khalid is right. Salman, again, there is some error in the power of 10 only. See, let's discuss it. Khalid, your answer is right. See, the general formula of potential energy is what? K, Q1, Q2 divided by R. So we just need to find out what is Q1, Q2, what is R, and we just have to put it in the general formula. Now, regarding Q1, it is 2 millicoulombs. So we have to convert it to millicoulombs. So milli is what? This is 10 to the power minus 3. This is Q1. This is 2 millicoulombs means 2 into 10 to the power minus 3 coulombs. Q2 is minus, Q2 is what? This is minus 3 microcoulombs. So this means minus 3 into micro is what? 10 to the power minus 6 coulombs. So you have Q1 with you, you have Q2 with you right now. Regarding the separation between them. Yes, Salman, what is the separation between them?
3.
No, in SI unit, in SI unit.
0.003. So that will be 3 into 10 minus
3 into 10 to the power minus
3.
minus 3, correct. Minus 3 meters. Now let us just put it in this formula. U is equal to what? U is equal to K. K is what? 9 into 10 to the power 9. This is 9 into 10 to the power 9. Now this is Q1. Q1 is 2 into 10 to the power minus 3 multiplied by Q2. Q2 is minus 3 into 10 to the power minus 6 divided by the separation between the two charges. The separation between the two charges is what? 3 into 10 to the power minus 3. So 3 gets cancelled. 10 to the power minus 3, 10 to the power minus 3 gets cancelled. See, 9 multiplied by 2. This is 18. Minus sign is there. 10 to the power 9 multiplied by 10 to the power minus 6. This is 10 to the power 3 joules. This is the potential energy. Now see, it is asking you work done to make the system. Work done to make the system is what? This work done is only converted into potential energy. It means this is the same work done that has been converted into potential energy. So answer of second part, work done to make the system, this will be minus 18 into 10 to the power 3 joules. Now see, if your energy means your potential energy is positive, if your potential energy is positive, if potential energy comes out positive, then means your system is unbounded. And if your potential energy is negative, it means your system is bounded. So what kind of potential energy are we getting? Negative or positive?
Negative.
So
Negative.
system is bounded or unbounded?
Bounded.
Bounded. System will be bounded right now. So it is asking us to decide whether the system is bounded or unbounded. So it will be system, since the potential energy is coming out to be negative. Potential energy, this is coming out to be negative. It shows that system is bounded. Negative potential energy shows only this. Bounded means what? Attracted, kept bounded together. That is represented through the negative sign of the potential energy. Fourth part says, if it is bounded, then what is the work done to break the system? We had calculated work done to make the system. If minus 18 into 10 to the power minus 3 joules is required to make the system, what do we have to calculate? We have to calculate what is the work done now to break this. So that will be definitely negative of the work done to make the system, because both of these are just opposite. So work done to break the system, this is equal to negative of, this is equal to minus work done to make the system. So this will be what? This work done to break the system will be positive 18 into 10 to the power 3 joules. And if this was our answer coming, that could easily show that the system is unbounded. Means work done System has already been broken, unbounded. Since we are getting negative sign, it means the system is now bounded, and this is the work done to make up the system. Clear? Easy? Just formula based. We'll do one more question on potential energy. If you have more charges, this was just 2 charges system, no? Just note it down, then we'll do one more question on it. So A, B, C, D. This is a square given to you. At A point, the charge is plus Q. At B point, the charge is plus 2Q. At C point, the charge is minus Q. And at D, this is minus 2Q. And the side of this square is A. You have to find out the potential energy. So let's discuss it together only. See, you have to find out potential energy of the system. It means now you don't have to find out the potential energy of a single charge. So you have to consider all the interactions that are possible, all the forces that will be generated, all the energy that we have to consider. See, Q1 and Q means at point A and at point B, Q and 2Q, they will be interacting. So we have this as first Q1 and Q and 2Q. This is the first one. Then this 2Q will be interacting with this minus Q, means they will also be having potential energy. So 1, 2. minus 2q will be interacting with minus q, third energy that we have, and plus q will be interacting with minus q, fourth energy that we have. So do we have 4 energies, or you think there are more energies possible, or this is it, 4 energies? Yes. Yes, class. Do you think 4 energies are possible, which I have discussed? Less than 4 or more than 4, or 4 are sufficient? Yes, Hania? Samaira?
4 are sufficient.
Hania? Hani, you there? Okay. At the center means what? There is no charge at the center, so there won't be any interaction. There is no charge kept over here. All the 4 charges are there at the corner only. Memuna?
Yes, teacher, 4 are enough.
4 are enough. Khalid? Yes, Khalid? Are you there, Khalid?
Yes, teacher.
Do you think this is enough? 4 energies are there in the system?
Yes.
Okay. All of you just see one thing. 4 charges are there, 4 energies are there. But you have to consider the possible number of interaction, because you are calculating the potential energy of the system. See, minus 2q and plus 2q will also be interacting diagonally. Plus q and minus q will also be having potential energy. So there will not be only 4 energies. The total energy possible in this is 6. Now after 6, no other energy is possible. 4 energies because of on the sides of the square, and 2 energies diagonally. Now see, all the energies are covered. 6 energies are possible. So you have to consider all the energies that are possible if it is talking about potential energy of the system. Now we have to find out the energy. So now this is easier. So rest of the separation we know. We don't know what is this separation. So as I've told you, this separation, if your side is A, this is always A root 2. Why? A square plus A square under root. Under root A square plus A square is what? AC will be under root small a square plus A square, that gives A root 2. So AC is A root 2, B, which is equal to BD. This is also equal to A root 2, this separation. Now we have all the charges with us. Now we have all the separation with us. It is very easy to calculate potential energy. Let's talk about the first potential energy that is there, A and B. So remember the general formula, don't forget it, K Q1 Q2 divided by R. Now let us talk about point A and point B. K, charge is what? Q, other charges 2Q, separation between A and B, this is small a. Next, so first energy, this has been considered, plus other charge 2q and minus q, this will be, now you have to consider minus, so kq means this minus q has been considered. Hania, see, at the center there is no charge, so at the center how will we have any potential energy? Had I kept a charge, fourth charge q4 over here, then this q4 would have been interacting with all these 4 charges. Now there is no charge at the center, so what will all these 4 charges be interacting at the center with? Okay, potential energy comes with only interaction. As I've told you, you have to calculate the interaction. So since there is no charge right now at the center, there is no possibility of potential energy. Had there been a fifth charge, Q5 or any 2, Q3, Q4, Q, then we would have been considering all the energies associated with that fifth charge as well. Is this clear, Hania?
Yes, ma'am. Thank you.
All right. So this is, we were calculating UBC. potential energy for B and C. So one charge is minus Q, other charge is 2Q, divided by the separation between them, A. So 2 second energy has been considered. Third energy between C and D. So this is what? This is K minus Q. Other charges minus 2Q. The separation between them is A. So 3, this energy is also being considered. Now this energy between plus Q and minus 2Q. K, one charge is Q, other charge is minus 2Q. Between the separation between them is small a. Fourth energy has also been considered. Now fifth energy, interaction between plus Q and minus Q. Both of them are also in contact with each other, so they'll be also exerting energy. This will be K. One charge is Q, other charge is minus Q, divided by the separation between them is A root 2. So this fifth energy has been considered. Now the last energy, minus 2Q and plus 2Q. So this is plus K minus 2Q plus 2Q, but the separation between them is A root 2. Is this clear to all of you how to write this? Now from here, anybody can solve. Is this clear till here? All of you?
Yes, sir.
All right. Now we just have to solve this. So this will be what? See, Q square is there in all of them, no? K Q square by A is there in all of them. We can take K Q square by A common only. Q square is common in all of them, yes. Now let's see whatever is common is left. So K Q square by A has been taken common. From here only 2 is left. K Q square by A has been common, minus 2 is left from here. K Q square by A is left, so plus 2 is left over here because minus minus becomes plus. K Q Q Q A has been taken, minus 2 is left. From here, K Q square by A has been taken, so minus 1 by root 2 is there because here we have root 2. And K Q Q by A has been taken, we have minus 4 by root 2 left. This is what is left. So 2 minus 2, 2 minus 2. This gets cancelled only. So potential energy will be what? You will be K Q square by A. And here it is minus 5. Okay, denominator is same. We can write it as minus 5 by root 2. So potential energy is minus 5 K Q square A root 2. Easy? Clear to all of you?
Yes,
Yes,
ma'am.
teacher.
So just note down this question as well. Okay, Hania, you can leave and come. So Hania, were you able to write before you left for the prayer?
Yes, ma'am. I was writing with you.
Okay, okay. So if it is written, then shall we move forward? All right. Now see, potential energy, just one case we have to do and then we are done with potential energy also. If we have a dipole, so potential energy of electric dipole. You have electric dipole present, then what will be the potential energy? So see, let's say these are the electric field lines. There is some potential kept, not potential, electric dipole is kept. In this manner, this is the direction. This is the direction, then definitely means here we have the negative charge and here we must be having the positive charge. And this is inclined to some angle theta. So this is inclined to some angle theta. Now, if you remember, we had done torque. What was the formula of torque in terms of potential, dipole and electric field?
PE sin theta.
PE sin theta, that is P cross E. Correct, Samaya. This is P cross E, which can also be written as PE sin theta. Now see, if you remember, I have told you the work of restoring torque is to align the dipole. So it will try to align it in this manner, so that electric field and dipole both get aligned together. Otherwise, it could have been aligned in this manner, but that wouldn't have resulted in alignment. If if the torque shifts the dipole in this it means what? This is the clockwise direction. So this is PE sin theta clockwise. This we have discussed in detail. How do we write clockwise? How do we write anti-clockwise? Now see, external torque acting on the dipole. The external torque acting on the dipole. This torque external is what? This is negative of this torque, the internal torque. So external torque will be what? External torque, this will also be PE sin theta with a negative sign, minus. I'm just writing the magnitude. P is magnitude, E is magnitude. Now see, work done. Work done is what? Work done is force into displacement. But angular work done is what? Angular force into angular displacement. And angular force, what do we mean by angular force? Angular force is this torque only, no? So whenever we are writing angular force means torque. Angular displacement means theta that we use. The angular shift. This is angular displacement. The shift in the angle that occurs. All right. So work done will be what? Work done will be, instead of writing F dot dx, the analog of force we have as torque, and dx we have it as d theta, from theta 1 to theta 2. Theta 1 be any angle to which it is shifting, or theta 2 be the other angle. Like if I'm talking about this, so from here it will be some theta 1 to the dipole is being shifted here to some theta 2. Theta 1 to theta 2. So this is the work done. Now putting the values of torque external as PE sin theta d theta, from where integrating theta 1 to theta 2. So does anyone remember what is the integral of sin theta? Salman, Khalid, you all are math students. Yes. Integral of sin theta gives what? Minus cos theta. All right, minus cos theta. So integral of sin theta gives minus cos theta. So this will be PE, are the constant that will come out. Integration of sin theta gives minus cos theta. Limits are from theta 1 to theta 2. it's not just cos theta, it is minus cos theta. Now the way we write in integration, we put the upper limits and lower limits. So work done will be what? Minus PE cos theta 2 means the final alignment angle, minus cos theta 1. I have taken this minus already common. So I'm just writing cos theta 2 minus cos theta 1. That's why we had practiced and revised integration once before we discussed and moved into the chapter. So this is the work done. Now potential energy. So you can get questions on work done also. So remember the formula of work done. And this work done gets stored in the form of potential energy. Work done, this gets stored in the form of potential energy. So potential energy will be what? This will be U2 minus U1. U2 minus U1, which is equal to minus PE cos this theta 2 minus cos theta 1. Minus PE cos theta 2 minus cos theta 1. Just in case if your theta 1 is 90 degree, means your dipole initially, if this was your electric field, initial position of dipole was like this. So theta 1 will be 0. So U1 will be 0 because not theta 1 will be 90 degrees and U1 will be cos 90 is what? 0. So you can write the potential energies formula then as U2 will be left because U1 is 0. So U2 will be minus PE cos theta 2. So any angle if you are given, this is just an example. If you are given any example, you can put it into the general formula minus PE cos theta 2. Remember again, we had discussed this also and we had done a question also. If you remember this, just rewrite this again. Work done by electric field. We had done a question if you remember. This was what? Negative of the work done by the external force. So if it is asking you what is the work done by the external field, and just put a negative sign to the work done by the electric field. Now if this is your general formula, no, PE cos theta, potential energy, general formula, it becomes PE cos theta minus P cos theta, or you can write it as P dot T also, minus P dot T. Now, if we write it in, let's discuss it in terms of three major cases that you get. If your dipole and electric field both are aligned together, this is your electric field, this is your dipole, both are aligned together already, means your theta is 0. Right now, I'm considering only one angle, PE cos theta, not the difference. We are assuming if the other angle is not there. So U will be what? This will be minus PE cos 0 degree. Cos 0 degree is 1. U will be minus PE. Minus PE, this is the minimum value. If this is the minimum value, it means it is the stable equilibrium. Whenever you have negative potential energy, your system will be bounded, it will be a stable equilibrium. This will be a stable equilibrium. If it is anti-parallel. If it is anti-parallel, then what will be theta? If this is direction of dipole, then what will be theta? Yes. Look at the figure that is given to you. If electric field and dipole are anti-parallel, what does this mean?
180 degree.
180 degree, absolutely right. Only Memuna can see this. Others cannot observe. P is in this manner, electric field in this manner. So angle, whenever it is written anti-parallel, that is known as 180 degree. The angle between them is 180 degree. So cos 180 is what? Minus 1. So this is minus PE cos 180 degrees. Now minus 1 multiplied by minus 1. U becomes what? U becomes positive PE. Now, this time your this will be the maximum potential energy possible. This will be the maximum value. This will be the maximum value and your equilibrium will be unstable. Your equilibrium will be unstable. This will be an unstable equilibrium case. Now, if your dipole and electric field are perpendicular, means this is your electric field, dipole is kept in this manner. Angle is what? 90 degree. So theta is 90 degree. U is equal to minus PE cos 90. Cos 90 is 0, so potential energy will be 0. Clear? Yes, yes or no?
Yes, ma'am.
So just note down this as well. Then we'll do a question on this.
Now we can like click control minus and then it will like zoom out. So then we can write at different places.
Yes?
Ma'am, you can just click control minus and then it will zoom out.
So the whole screen is not visible to you right now?
No, like we can see only the part you are able to see. You see?
I'm not able to get it, Salman. What are you saying?
Okay, ma'am. Never mind. Never mind.
Okay, Salman, you're saying so the area, okay. Did it get? I tried it. No, Salman, it's not working.
Oh, okay, ma'am. I have to check.
Teacher, can you scroll a little up? Okay, teacher, done.
Just text me done, all of you, when you have written the question as well. Just the question at least. Till the question and the theory part, just text me done in the chat box.
Teacher, in the above equations, I didn't understand how cos is there. Like it should be signed, right?
Cos, because we have integrated, no? Work done has been integrated. So that sine theta now has been converted into cos theta. The
Okay,
conversion.
teacher.
Okay. All right. So if all of you have written, this is for today. We'll just discuss this question on Wednesday. Other